So good morning. My name's Dave Rogers. I'm a systems engineer in the same team as James, UK and Ireland Enterprise Networking. I'm here to introduce to you the first half of our part of the virtualization story of digital network architecture. So the bottom pillar that we talked about virtualization, enterprise network function virtualization is the section we're going to cover here, and then transport virtualization, James is going to cover in a later section. Just to set the scene, what I want to just do as to start is just to get clear what we're talking about applications in the branch and functions in the branch and why we need tools to virtualize these and why we need to manage those. And to do that, I'm going to take you just on a quick journey back across the areas we're familiar with about application structures on the web and show you how what we've been doing to optimize the different technologies in the data center in the cloud, out in the mobile clients, are now principles that we're following exactly the same way out at the branch. So that's where we're expecting to see the same kind of level of benefits as they come forwards. So initially, our web model was to start off with very thin clients, very tiny payloads going across very restricted communications, whether it's WAN links, back in the ISDN days, for example, and all our compute took place remotely in data centers or nowadays in cloud. As we grew this infrastructure and grew these services, what we ended up with was lots and lots and lots and lots and lots of hardware appliances in our data center, and we optimized that by virtualizing those hardware appliances and those applications into the cloud kind of models that we have today with the tools that we have today for managing virtual machines. We then moved into the next kind of generation where we put computing capability at the edge of the network. So your phones, your smartphones now gave us the capability to actually do some processing work out at the edge of the network. And there we could then we were still restricted in terms of the payloads that we could move and HTTP protocols that we use here, but we could take we could use the compute here for the really big things like your global maps, and we could use the local compute on the clients to do the local analytics to work out where exactly am I, whether it's on a Wi-Fi network or on a GPS, and be able to then combine the two. And the reason that this whole model scaled compared to when we just had phones and we just had sat-nav devices and we had our Sony Walkmans and we had a series of devices was we started to virtualize all those hardware applications into apps on the phones, and we built the infrastructure to be able to deploy those apps out to the edge of the network and connect them with the services that we had in the cloud. So in the branch, right, we have this same model. Right? What we've actually had is some services still need to have something more of this compute capability out at the edge of the network. It's usually for things that have to be immediate and available, maybe before the phone knows exactly where it is to help it find where it is. It may be that we need processing capability here that's going to be more suited, or it's less battery intensive, for example, for the phones. It's something that we need to be able to process out there. The kind of things we're talking about are things like when we cache content, Akamai as an example, when we push video out so we get high quality video across the Wi-Fi network instead of being constrained by this link to the data center. DHCP, WAS services, network services, wireless LAN controllers, they're all things that we need to put in the branch to optimize that experience. But the problem is we don't have the kind of scale and the tools that we built in these other parts of the networks. So what we end up with is a whole stack of different appliances to deliver these branch services and branch network functions. And then that gives us the problem of the hardware refresh cycles. We've got companies that have like a 7-month refresh cycle. As soon as they get through a refresh of one set of hardware, the same team starts another refresh. All they're doing is refreshing hardware out in the branches. And it's different for each different vendor. It's different tools for the same vendor, for example. And so what we're doing here is saying we should take the lessons that we've learnt for these other technologies. We've been virtualizing these and making them available over the last 4 years or so. And we've been having the Open NFV consortium, for example, driving this. But the important thing now that we're adding is the set of tools that allow us to deploy these out and manage these services out in the branch in the same way that we had those tools that allowed us to manage our virtualized networks, either in the data center or in the clients. And this is what Cisco Enterprise Network Function Virtualization is all about. We're going to go through some of those components. When we talk about this, the first question is, well, we've had this NFV thing around for a bit. we've got tools like ESXi, VMware. Why don't we use those? These tools, they're good for providing services at fixed points out in the network. Yeah? But when you're actually changing the underlying network, when you're putting a router and then a firewall and then another service behind that, you need to actually chain these services together. You need to build them in the right order. And when they're all together, it all works. But if you start with a tool that just thinks it has a pool of computing and can just load these services up, like it does in the data center, the orchestration part of that, that's specific to the branch, may mean that either you've got to do it by hand or those tools don't work. So we've seen in customer scenarios that some of the tools that exist already today, we think, let's just try and use those, move them from the data center to the branch, do give us other problems. And Enterprise NFV is trying to solve those problems for you and make it really easy. Now, the easiest way to get a handle on this, and I'm recommending this to everybody, is instead of me trying to demonstrate this or spend 40 minutes talking through, is we have a published video on the web, which in 5 minutes gives you the whole story right from the beginning, what it's doing, how it works, what it's going to do. So yeah, so as I say, I just recommend that you use that. It is so easy to get an overall view and just to see all the different components in one place to then be, and because it's a nice handy video, if you're halfway through a demo, you've got to go back and undo things to show, I missed that bit at the beginning. You can go backwards and forwards through this as well to really just drill down to, have you got the steps and do you understand this? What the great thing is there, that you saw effectively a complete branch being stood up, but you didn't see a CLI. This is what we're talking about, DNA, orchestration, automation, fixed policies that we can then push out across the network. Yeah? So we're going to just go through and give you a quick overview of some of the proof points within the architecture here, and some of the things that we're working on that will make this a more effective solution as we understand how it works. So the main components you saw there were the enterprise service automation, the management portal on top of this. This today sits on top of APKM and Prime infrastructure and uses their northbound APIs to be able to orchestrate and set up the boxes and be able to set up the virtual services underneath. Yeah? The client side of this, actually managing what's going on in the branch boxes, is our network function virtualization infrastructure software. We'll explain that in a moment. Yeah? That runs on UCS platforms, Cisco UCS platforms of some sort that are out in the branch, and is used to manage the deployment and the service chaining of the virtual network functions that you've seen here. Now, the one point I will make here is that as well as the 4 Cisco functions, network functions that are supported on day one as we start the rollout of this platform, we do also tend to keep this completely open. It's an open platform. We're effectively deploying virtual machines, but with specific virtual functions. But we will also be supporting deployment of Windows virtual machines, Linux virtual machines. We have third-party network vendors who provide those appliances who are working with us to certify their NFVs so that they can run on this platform as well. And this bit is going to be the part that makes this really interesting as we learn how it deploys and as we go in the future. So our vision for NFV is not simply to deploy the network components out at the branches, but this is a foundation for a platform that will eventually be able to deploy other applications that you and your customers need at the networks. That might be some of these analytics kind of tools that we're talking about. It might be point of sale terminal tool, services. It might be that you put, we have another model where when we walk into a store, all the maps for the store are served from a local application in the branch instead of 1,000 people downloading the map of the store across your WAN link. So there's all sorts of possibilities and opportunities by having this more open, and that's going to be the area to explore with your customers as we go forwards. We also talk about running applications natively on our ISR 4Ks. We've got a couple of slides to show how that works, but we're developing a similar model, but the ISR 4K is managed separately from this. NFVIS works on these x86 UCS platforms out in the branch. So NFVIS, this is a purpose-built operating system that we've developed to provide the client side of this orchestration processing. It starts with a plug-and-play client that can talk to APKM that can actually be used for zero-touch deployment of the UCS part of the platform out in the branch. So this works in the same way. We talk about plug and play later on in the day. This works in the same way to be able to give you real fast automation of getting the hardware up and running in the branch. Then we provide the monitoring of the NFVs, the virtual network functions. We provide the APIs that are necessary to manage and deploy those. And then there's another web portal that we can get onto here to manage this directly. And all of this is all packaged within the operating system we deliver at the client side to talk to ESA. Now, the one key thing I mentioned earlier on that's important about this is this service chaining. If you've just got a pool of compute and you just put services in there, it doesn't really matter quite how you put them in there. But when you've got to have a firewall that sits behind a router, or you've got to have WAN optimization in the middle, you have to chain these applications together in the right way. And that's what's happening. When you create these policies in ESA, it's effectively then automating that whole workload of standing these up in the right order and chaining them together in the right order. Right? And the reason you can see why maybe it's a good idea to take a tool from Cisco to do that is if you've just got an AVA file that you want to deploy for a firewall, in this situation, you're going to configure that so that it's talking directly to the backend IP address of the router. In another configuration, this may be chained behind other devices. So each of these different scenarios, although your core network function will start the same, when you deploy it, you maybe want it configured differently, and ESA manages that for you. So what actually happens under the hood here is inside the operating system, we have a KVM hypervisor, an open source hypervisor that we use within the software, which is used to stand up the virtual machines in here. We use Open vSwitch to provide the connectivity between the VMs within the infrastructure itself. Yeah? And then we then provide from NFVIS, we then provide the connectivity that then takes us off to the WAN and off to the other parts of the network. Yeah? So the service chaining all takes place by effectively setting up, in the first instance, bridged networks inside Open vSwitch. And we make sure then that the traffic you need to go through all these different paths takes place from A to B, from where you've got your clients to where you hit your routing. Now, the one issue that we have as we look at this and scale this is being a software, an open software platform that we use here. As we start to move traffic from A to B, each time we do this, in effect, we're interrupting the CPU of the box to be able to handle the packet flows through here. So one of the areas that we know about that we can optimize in here is take away the traffic load and the CPU load on the main platform as we start to get more traffic through here. So what we're actually looking at, and what we're going to be announcing at the end of July, is an optimized compute platform that will sit in the branch. Now this is, instead of just a plain UCS, this is a UCS box. It's an x86 platform with a number of cores, amount of memory, but it also has specific features that make it really optimized for network function virtualization and working with ESA. For example, it has hardware acceleration built in for this VM traffic. So this will be, if you had a plain off-the-shelf server, you'd be routing all that traffic in software. If you have this server here, you'll be routing all that VM to VM traffic inside the hardware, inside the switch itself, inside the box. We also have here an integrated switch, 8 ports with PoE on the higher end models as well. So if you want to put access points into here, and this is starting, you see how this is starting to become a one branch in a box kind of solution here. It also has a network interface module here, and it doesn't support all the network interfaces that we have in our portfolio, but as we add support for the different network interfaces in here, so you'll get more variety. But you can have this as the router, the switch, and the network function virtualization platform all in one box. Now, just remember on the diagram we showed you up there, network function virtualization covers these platforms where we've effectively got a UCS, an x86 box, alongside our network, our core network. Yeah? There is another model that runs very similar to this. It's been designed in the same way, where in certain scenarios, we will support putting network functions in the same kind of way directly on the ISR 4K itself without having an additional UCS or x86 blade to run it. Yeah? And that's what we call service containers in ISXE. Yeah? And what effectively we're doing here is, because we're running them on the router in a space on the router without a separate platform alongside that, right? Obviously, it's going to be more lightweight. You're not going to run a call center on your ISR, right, inside the same part of the box that's actually doing your network functions for your network routing, for example. But lightweight applications, services that we support services on here for wires, for example. But we also, where we need network functions that need to be right at the edge and right tied into the core ISR platform, we do that. And this slide just gives you some idea of, we have the same model under here. It's built in a different way, it comes from a different scenario, right? But we're still using KVM, or we're still using Linux containers to be able to deploy these services on those branch routers. And we'll give you another example later on today to give you an idea of what Cisco IT is doing with this inside our own network to be able to get functions, analytics functions deployed quickly and easily across the network. So, all right, we're obviously at early stages on this, so we're giving you a sort of preview of where it goes. These are the good things that you need to start to look at. There is a vision white paper which talks in depth about how these things all fit together. Yeah? The ENFE site was where you saw the video, linked up from where you saw the video earlier on. As SEs, we need to get our heads around some of these slightly different ways of different hypervisor technology. We use KVM as its open source, rather than some of the other hypervisors here. And some of the tools, the Linux tools that we need to manage so we understand what this box is doing and what's happening inside NFVIS. Right? As we go forward in time, moving these applications out to lightweight solutions in a branch, we're going to need to understand as SEs the differences between deploying virtual machines and applications in virtual machines and deploying containers. Yeah? We are deploying virtual machines, right? And we're using LXC on the ISR 4K. Yeah? But we need to understand how to position those different approaches so that people don't go, oh, fantastic, I've got this great app I've been doing on Docker. Can I just stick it on my ISR 4K without understanding how the technology works? Yeah? We will have service container and ESA demos are coming on dCloud, so you'll soon be able to see those and play with them and understand them as well. Yeah? And our Cisco, I'm going to be on this. We've got the deep dive training on this part is taking place in the last week of July. So Cisco engineers are getting up to speed on this real nuts and bolts technology in the field here to help you out as we go forwards there. And the other thing then is to get your strategy ready with your customers. Start talking about what are the pain points of managing these different services and applications out of the branch, all the refresh cycles they're going through, multi-vendor kind of issues. Yeah? What kind of applications do they think could really help them with customer experience, workforce experience in the future if it was easier to deploy them than it is today? Right? And use this demo as a talking point to open up the conversation about how to manage branch applications. And then finally, we're going to close later on about this relies on APIC EM inside your network. We talked about that earlier on. Later, we're going to show you a step-by-step process of where you can, measuring yourself and where you are with the customer on going from just hearing about this in PowerPoint to being able to have APIC EM ready and up and running so that services, value-added services like ENFV can be deployed. So finally, I'm just going to end on this one slide, which just puts the hardware in perspective here. We have the physical router, the ISR 4K solution. This is natively running on the platform. Very lightweight kind of applications, very specific network function applications. Under ESA and Enterprise NFV, then, we have, you can stick a UCS series behind the existing switch and routing, and you can then deploy virtual services on top of that. Yeah? But everything in here is software only. So when we're talking about the vSwitch, for example, that's just a software platform running on an x86 server. Yeah? But this can scale those services much quicker and easier. At the next level here, we have the sort of compromise where we have, it's a lower level of compute, but we have the integrated services here. So a simple branch in a box kind of solution, small number of virtual functions that we want to run there, being able to stand that, right, with the WAN connectivity, the switch connectivity, PoE, ENCS will fit into that bracket. But if you want anything complicated for your WAN uplinks, for example, if you want full functions on your network side of things, and you want NFV to sit on top of that, then go for the full ISR 4K platform, which gives you the core network connectivity that you need to be able to get diverse paths, different WAN connectivity that you're already used to, and then use the UCSE inside that platform to make it an easy single box management and single box deployment to be able to add these virtual services on top. So that's where we see as choice of services, choice of capabilities to be able to deploy optimally applications starting with network functions out in the branch.